So here we have another example of a chi-square test for independence. So our example 2 says a researcher is interested in investigating whether religious affiliation and the brand of sneakers that people wear are associated. The table below shows the results of a survey. So it looks like frequencies of religions and sneakers. So I have the religions, right, are my row, and then my columns, right, are the sneakers. And so it says what can be concluded in alpha equals 0.05 significance level. So A says what is the correct statistical test to use? So because it says the brand of sneakers that people wear are associated, right? Associated, they're wanting to know, are they independent or dependent? So if we're looking at whether they're independent or dependent, this is a chi-square test for independence. So a chi-square test for independence. And I believe if you're doing this on your homework, it'll have sort of a drop-down menu, but the chi-square test for independence is the one that you'd want to choose. So B says, what are the null and alternative hypotheses? So remember, the null always has the idea that the variables are independent, and the alternative is the variables are dependent. So our two variables, right, so we would say that religious affiliation and brand of sneakers are independent. And our alternative is that religious affiliation and brand of sneakers are dependent. Okay. So our next couple questions, right? Test statistic, p-value. This is all going to be found on our calculator. So what we need to do now is enter our contingency table as a matrix into our calculator. So to get into matrix, we'll hit second and matrix. Now I have some already stored from before. We're going to use A and just go over and edit and hit enter. Now we have 1, 2, 3, 4. So we still have a 4 by 1, 2, 3, right? 3 matrix. So we're good here. So we'll just go through. And now we want to go through, and there's no really, I guess, easy way to delete all these. So I'll just go through and over type on them. So 80, 82, 112, 52, 58, 100, 15, 21, 27, 87, 65, and 78. Okay. So now that I'm done, I can quit out of there. So second and quit. Now this one's not asking for expected values. So the calculator will calculate them behind the scenes, but we don't need to go back and look at them. So we want that test statistic, so we'll hit our stat button, go over to test, and I just arrow up because it's a little bit faster. So we want the chi-square test and hit enter. The defaulted should be A and B, so we'll calculate that. And so my chi-square test statistic, right, so chi-squared is going to be 13.25, rounded to 2 decimal places. My p-value, right, rounded to 4 decimal places, 0.0393. Now, if I compare it 0.0393 with our significance level of 0.05, the p-value is, we'd say, less than, right, less than alpha. And based on this, right, if alpha is, alpha is greater than the p-value, so we are going to reject the null. So reject the null. So we should be concluding, right, that the religious affiliation and brand of sneakers are dependent, right, because we're concluding the alternative. And so it says, thus the final conclusion is, so we're looking for they are dependent, right? So we can cross out anything that doesn't have that idea of dependent, right? This is talking about the distribution. That's not what we want. So it says, we'd say there is sufficient evidence to conclude that sneaker brand and religious affiliation are dependent, right? So we would choose this one here because the first one says there is insufficient evidence, which we're concluding there is. So that would be my conclusion for this one. Now, the last example I have is just how do I find the degrees of freedom for a chi-square test for independence without the calculator? So maybe it just wants the degrees of freedom, and you don't want to have to go through and enter all of this data into your calculator, to find that the degrees of freedom for the last one was 6. So remember, the degrees of freedom, if I scroll all the way back up to the beginning of our notes, you can see that it's the number of columns minus 1 times the number of rows. So a lot of times they'll say column minus 1 times row minus 1, okay? So for our case, we want to know the columns, right? For our last example, if we calculate this, right, our columns in our last example was 3 and our rows was 4. So I have columns, so 3 minus 1 times 4 minus 1. So 3 minus 1 is 2, 4 minus 1 is 3, right? 2 times 3 gives me that degrees of freedom of 6. So again, you'll see for some of your homework, they'll ask you what the degrees of freedom is. And so without really needing much information, as long as you know the columns and the rows, you can identify what the degrees of freedom will be for your chi-square test for independence.